The body mass index I of a person weighing W kilograms and has a height of h meters is given by the formula I equals W over h squared. We would like to estimate the body mass index of a person weighing 101.6 kilograms with a height of 1.98 meters. So to do this, we will notice that 101.6 kilograms is very close to 100 kilograms, and 1.98 meters is very close to 2 meters, and we can calculate the body mass index of a person weighing 100 kilograms with height 2 meters. We can calculate that exactly from this formula easily. It's 100 divided by 2 squared. 100 divided by 4 is 25. So a person with these characteristics would have a body mass index of 25. So we would expect the person with the given characteristics to have a body mass index close to this. But the actual formula would give us 101.6 divided by 1.98 squared. And let's say we don't want to compute that. Instead, we want to estimate it. So what we will do is we will think of this. This is a surface in 3 dimensions. It's a surface in the IWH space. And we will think of this surface as being a level surface to the function g of IWH is equal to I minus W over h squared. And then we'll make the tangent plane to this, so this equals 0, to the level, well, that's the function. So the level surface, g of IWH equals 0, that's a level surface. So we're going to find the tangent plane to this level surface at the point I is 25, W is 100, H is 2. So we're going to find the tangent plane at this point and then use the tangent plane to estimate the body mass index if the weight and the height are these given numbers, 101.6 and 1.98. So in order to calculate the tangent plane, we need the gradient of g. So the gradient of g at any point IWH, and in the order that I've written the variables, this would be g sub I, g sub W, g sub h, and the function g is here. So g sub I, the derivative of I is 1. There's no I there, so that's a constant. The derivative of W, 0 minus 1 over h squared is a constant, so negative 1 over h squared. And then g sub h, so the derivative with respect to x of 1 over x squared is negative 2 over x cubed using the power rule, because this is x to the negative 2, and then the derivative is negative 2x to the negative 3, which is that guy right there. So this is going to be, we have a negative in front, so that's going to drop out. The W is just going to sit there. So we have 2W over h cubed. So this is our gradient vector. And if we want the tangent plane at this point, then we want the gradient vector at the point 25, 100, 2. So we have IWH. So this is just a 1. So that's just going to stay a 1. Negative 1 over h squared. H is last. So negative 1 over 4. 2 squared is 4. And then 2w over h cubed. This one's w. 2w is 200. Divided by h is 2. Cubed, that's 8. 2 cubed is 8. And 8 goes into 225 times. So this is our gradient vector. And now the tangent plane to this level surface here, g equals 0, at the point 25, 100, 2, we take the gradient vector that we just created, and we take the dot product of that with a vector in the plane. So a vector in the plane has one endpoint being just some random IWH, and the other is 25, 102. Those are 2 points in the plane, and the vector connecting them is I minus 25, W minus 100, H minus 2. And the gradient vector will be perpendicular to the level surface, and therefore this dot product will be 0, because this vector will be in the tangent plane. And this one's perpendicular to the surface and therefore also perpendicular to the tangent plane. So this is how we make the equation of a tangent plane. Gradient dot vector in the plane equals 0. And this gives us the equation I minus 25 plus, well, I should say minus, and good thing I drew my plus line in the wrong place, minus 1/4 times W minus 100 plus 25 times H minus 2 is equal to 0. And we can solve this for I by just putting these two terms to the other side and the 25 as well. So I, the I coordinate of a point in the tangent plane, is 25 plus 1/4 times W minus 100 minus 25 times H minus 2. And this is the tangent plane, so we'll call this T of WH. This will give us the height of the tangent plane at any weight and height. And so our body mass index for a person with these parameters will be approximately, instead of plugging the W and the H into this formula and getting this quantity, we will instead plug the W and the H into the tangent plane here, and that will give us this quantity. So this I is approximately T of 101.6, 1.98. Plug those numbers in to the tangent plane, and we get 25 plus 1/4 times 101.6 minus 100. So 101.6 minus 100 is 1.6. And then minus 25 times H minus 2. Our H is 1.98 minus 2 is negative 0.02. And then this turns out to be 25 plus 0.4. 1/4 of 1.6 is 0.4, and then this is a double negative, so a plus. 25 times 0.02 is 0.50, so 0.5, and this is 25.9. So our estimate for the body mass index of a person weighing 101.6 and with a height of 1.98 is 25.9. And we can break out a calculator and figure out this number, and it should be close to 25.9. That's our estimate using the tangent plane. And we can notice as a shortcut for this formula here that this equation just boils down to this 25 was the body mass index at the point that was the nice point that was near 101.6, 1.98, and then plus and 1/4, negative 25, that would have just been the gradient of this original function dotted with W minus 100, H minus 2.